Alright, so we're going to take a look at sketching derivatives. Go ahead and make a new tab. Alright, so that's our new tab. 2 lines all the way down. Alright, we'll just stick it in. I'm just going to title sketching derivatives here at the bottom. There's really not much work to this. A lot of it is just us talking through it. Take a minute to look at the graph below and see if you can rationalize why cosine of x should be the derivative sign. So we already know that it goes sine, cosine minus sine, negative cosine, but why is that true? Alright, so notice that whenever sine has a maximum or a minimum, at that point the tangent line is going to be 0. So you see where it has a maximum minimum, you draw a tangent line and you can see it's horizontal, so that means the slope is equal to 0. So at that point it's equal to 0, so these 2 points right here. The value of the cosine function is 0. Notice that whenever sine has a maximum slope where it passes through y equals 0, the cosine function reaches a minimum at plus or minus 1. Let's look back at what we've previously proven. So we remember when you had the graph sine of x and we're drawing a tangent and we're combining those 2 graphs to look like that. What happens as x got really close to 0? Well, as x got really close to 0, remember we got sine x over x is equal to 1. And now it was positive because the tangent was going up. In this case, if we look right here, it's negative because it's going down. So that would mean that it would be negative 1. So versus positive 1, this would be negative 1 because it's a downward slope. So really at those points of inflection where the slope begins to change at maximum, the tangent line would be very close to the original, which would make it positive. Now because this one's going up, it'll be positive. And over here, because it's also going up, that would also be positive 1. Because it was going down through 0, it would be negative 1. And then you could just join the dots and you can see that you get cosine. Alright, so to kind of walk us through, we're going to find the horizontal tangents. At those points it's going to be 0, so we're going to label it 0. Alright, then we're going to look at what's happening between those things. Okay, so let's look at what's happening between those. So from A to B, what's happening? The slope is falling, the tangent is negative, which means then it needs to be negative. So we're going to draw a negative line or curve. From B to C, it's positive. So that means it has to be positive between those 2 things. So I'm going to draw like a little hump because it has to come back to 0. So that's why it's positive. It's in the positive, but it has to come back to 0. At that point, the slope is negative, so it has to be negative. But it has to come back to 0 because we're going to change from negative to positive. I'm just going to make it steeper because, you know, from B to C, it's a little bit more steeper than I drew it. So I'm just going to make it steeper. And then from C to D is a little shallower than that. Then from D to E, what's happening with the tangent? It's positive, so it needs to be positive in your derivative. And this is pretty much all there is to it. It may be a little bit confusing, but you don't have to get an exact graph. You just need to know what it looks like. This is more likely to be like a multiple choice question until we get to where we actually sketch graphs with maximums and minimums, etc., etc. Alright, so let's say he started off with the squared function. So draw what the squared function looks like, just like this. This is a listening check. Color in f of x equals x squared. Color in f of x equals x squared. Alright, so we're going to go through steps. So let's say step 1 says graph the original function. Number 2, find the horizontal tangent. That means the slope is equal to 0. And graph those points. Now, step 3, between the horizontal tangent, what's going on with the slope of the function? This is a listening check. Put a box around the word between. Put a box around the word between. If it's decreasing, it's a negative. If it's increasing, it's positive. Alright, so let's actually apply that. Okay, so let's find the horizontal tangents right there. So that means it goes to the point 0, 0. And then let's take a look at what's happening. All these tangents are decreasing, which means it's negative. So it would be a negative value. And then after that point, all these tangents are increasing, so it'll be a positive. And that's pretty much it. And that makes sense because we know the derivative of x squared is 2x, which is a straight line. Alright, let's take a look at another example. Alright, this is the x cubed function. Alright, so let's find any horizontal tangents, and it only happens once at 0, 0 because you can see that it changes. I don't know how to explain that, but it changes from going one way to the other. So it's at that point the slope is 0 because it has to change in order to change direction, so to speak. Alright, so there's 0 there, and then what's happening? It's increasing from that side. so it's positive. And then on the right hand side it's also increasing, so that's also positive. So it looks kind of like this. So that makes sense because we know the derivative of x cubed is 2x squared. Alright, so a rough idea. Alright, let's take a look at another example. This one doesn't really have a function, but we're still going to be able to figure out or sketch the derivative of it. So let's say it looks like this. Find any horizontal ones where the slope is 0, so I can see right there is a horizontal, so I go through 0, at 0 it goes through there, and over there it goes through there. So mark those points. Then ask yourself what's happening between those 2 points. Over there it's decreasing, so that means it's negative. From after that to the next one it's increasing, that means it's positive, but it has to come back to that point at 0. So it's got to be some kind of a curve, yep, like that. And then from there it's increasing, so it's got to be positive, but I have to come back to 0. So just like that. And then after that point where the slope is horizontal, the tangent line is decreasing, so it's negative. So something like this. And again, it doesn't have to be exact, it's just a sketch. I'm just going to color the lines differently so I can differentiate which one was which. This is a listening check, underline negative. This is a listening check, underline the word negative. And that's pretty much it. Let's practice.